Given the graph of this function f, we're asked to find a whole bunch of things. My ink started running out, so let me read them to you. Part A, find f of 0 and f of 3. Part B, find f of -1 and f of 1. Part C, find f of 2. Is f of 2 positive? Part D, is f of -1.5 positive? Part E, for what values of x is f of x equal to 0? Part F, for what values of x is f of x less than 0? Part G, find the domain of f. Part H, find the range of f. That's all possible y values. Part I, what are the x-intercepts? That was part I. Now part J, what are the y-intercepts? Part K, how often does the line y equals -1 intersect the graph? Part L, how often does the line x equal +1 intersect the graph? Part M, for approximately what values of x does f of x equal 1.5? And then part N, does a graph pass vertical line test? Whew, wow. Okay, let's start with part A. Find f of 0 and f of 3. Well, f of 0 is defined to be equal to the y partner of x equals 0. So you just look at the ordered pair on the graph that has an x coordinate that's 0, and you'll see that its y partner is the 2. Okay, that comes from the ordered pair 0, 2. Now f of a is the y partner, f of 3, of x equal 3. So find the x value 3 and go to the graph and find the y partner. It's at the level of about between 1 and 2, so it's about 1.5. All right, so we found the y partners. We're going to part B, f of -1. Well, by definition, f of -1 is the y partner on the graph of x equals -1. So go to the graph, look at -1, look at the y partner. It's at 0. The y level is 0. And then f of +1 is equal to the y partner of x equal 1. So go to the 1 on the x-axis and go up to the graph and read the y partner on the y-axis. It's +1. Okay, let's see. What shall we do next? Well, we're going to say what these results tell us. We have an ordered pair 0, 2 for part A and an ordered pair 3, 1.5. And then for part B, we have an ordered pair -1, 0 and ordered pair 1, 1. Those are all points that live on the graph. That's what we found. But the answers are boxed. Part C, f of 2. Look at the graph. We're looking for the y partner of x equals 2. So we look at the x value 2 and we move up, find the y partner. It's equal to 1. So that question for part C was not what is f of 2. The question for part C is f of 2 positive? Well, it's equal to 1. All right, the point on the graph when x is equal to 2 is above the x-axis, so yes, it's positive. It's actually equal to 1 approximately, but it's definitely above the x-axis, which makes it positive. And then let's see. So we take that result and go to part D. Part D says, is f of -1.5 positive? Well, look at x equals -1.5. That's -1.5 between -1 and -2. Go down to the point on the graph and you see its y partner is approximately between -1 and -2 on the y-axis. So it's negative. It's below the x-axis. Yes, it's negative. Part C, f of -2. Part E. For what value of x does, this is part E, for what values of x is f of x equal to 0? Well, let's see. They're asking me for what values of x is the y partner 0. You know what? When the y partner is 0, those are x-intercepts. I can just read those right off the graph. Let's see. So we're going to have it when x is equal to -2, when x is equal to -1. So the answer is the set of x values for which the y partner is 0 is -2 and -1. Those are the x coordinates and the x-intercepts. Part F, for what values of x is the y partner less than 0? Okay, so what does that mean? To say f of x is less than 0 means that the y partner lives below the x-axis. Okay, so We're searching for the x values where the y partners live below the x-axis. There's going to be a whole bunch of them. The x values for which this occurs are on an interval of x values. And that interval, if you look at the graph, occurs where the graph is below the x-axis. That happens between -2 and -1. So we have the open interval from -2 to -1. It doesn't happen at -2 exactly because it's actually equal to 0. It's not less than 0 there. And the same for -1. Part G, find the domain of the function. It's all possible x values. The smallest value is equal to the -2, and the largest value of x is 3. And it includes -2 and 3, so we have boxy brackets. But part H asks us for the range, so we want the y, the smallest y, and the largest y. So it's -1.5, comma, and then the largest is 2. That's the interval of y values that are in the range. And you'll notice again we use boxy brackets because these points actually, the point that corresponds to y equals -1.5 and the point that corresponds to y equals 2 actually live on the graph. There's not an open circle. Okay, part I, what are the x-intercepts? Well, it's the same answer as, let's see, part E. It's the x values. Well, we'll write it as ordered pairs, though. The x values that have a 0 for a y partner. That's -2, 0 for xy, and the ordered pair -1, 0 for xy. So these are ordered pairs. They're not intervals. Those are ordered pairs of the x-intercepts. The y-intercepts are the values for which the x-coordinate equals 0. And if you look at the graph, they're the points where the graph crosses the y-axis. This happens only one time for functions. Because if it happened more than once, if you had more than one y-intercept, you would not have a function. It would fail the vertical line test. So the ordered pair for the y-intercept is 0, 2. xy equals 0, 2. Okay, now we're looking at K. K asks us, how often does the line y equal -1 cross the graph? Well, I'm going to actually imagine that I'm going to draw a dotted line there at y equals -1. It's a horizontal line. It passes through the ordered pair 0, -1. I'm drawing it with a dotted line. And it goes through, it touches the graph how many times? Let's see. It touches the graph. The line y equal -1 is a horizontal line. It touches the graph only twice, my bad. It crosses the graph twice. The horizontal line crosses the graph twice. Okay, now the line x equals +1, where does, the question is, how often does that line intersect the graph? Well, the line x equals +1 is a vertical line that passes through the ordered pair xy equals 1, 0. And it crosses our graph one time. It better not cross more than once because then this function is not a function because it would fail the vertical line test. Part M, for approximately what values of x does f of x equal 1.5? So they're asking what is the x partner to y equals 1.5? Look at the graph. It looks like the x is approximately 1.5 also on the graph. That has the y partner 1.5. Once again, f of x equals 1.5 is means that we're looking for the x value for which the y partner is 1.5. And the last part, N, does the graph pass the vertical line test? Well, yes, it does. It passes. And that means that there's no vertical line that crosses the graph in more than one place. And indeed, that's why they call it F. We don't name these graphs a letter like F or G or H unless they indeed do pass the vertical line test, that they are a function.